Everyone, I am Vinodhini. I welcome you all this lecture series of design analysis of algorithm. Today's topic is mathematical analysis of non-recursive algorithm. We know that what is a mathematical analysis. So the mathematical analysis is very important for every algorithms. So the performance of the algorithm is evaluated based upon this analysis. For that analysis, the two main complexity is very important. So based upon the time and space complexity, the algorithm is analyzed, and also the efficiency of an algorithm is calculated based upon that best case, worst case and an average case efficiencies. So today's topics we are going to see about how to analyze the non-recursive. We have a general plan for that. So for the two examples we have analyzes the non-recursive algorithms, how it is analyzed. So for example, in the first example is in finding the largest value in the list of n numbers. So what is an algorithm? So in that given array we have to find which element is a very maximum element out of a n number of elements. So the algorithms, you know that already, you know how to write an algorithm. So first we have to describe the problem description and what is the input and what is an output. So follow that, what is a pseudocode and what is the important term in the algorithms. First, in the given array, the array elements in the index are listed out a of 0 to a of n. So the maximum value we are assigning a of 0 as the maximum value. First we are assigning that. So next we follow that, we have the for loop, the for I is equal to 1 to n minus 1 do we have to do. So what is the 1? That is the next to a of 0. So 1 to n minus 1 for the for loop, the following if condition is evaluated. If a of I is greater than the maximum value, the maximum value is equal to a of I. These two statements is very important for finding the maximum of maximum element in the given array. So finally it returns the maximum value. The maximum value variable store the maximum value in the given array. So for that there is a main statement is first we have to assign a of 0 to maximum value. So where there is a for loop, that for loop is executed from 1 to n minus 1. So for that inside the for loop we have the if condition. That is a very important basic operation in these algorithms. So that is a of I is greater than the maximum value. So if it is appadina, the maximum value is assigned, the a of I value is assigned to the max value. So finally it return the max value. So in that first we have to analyze this, what is the problem size. The problem size of the given algorithm is n. So next thing we have to find out what is the basic operation. The basic operation for this algorithm is a comparison in the for loop. So the comparison means if a of I is greater than the maximum value or not. So next third term is we have to find out what is the count of basic operation. So how much time that basic operation is executed. So the for loop, based on the for loop execution, the basic operation is executed. So the count of basic operation is equal to summation of I is equal to 1 to n minus 1, that is equal to 1. So the base, you know that from the formula we find out that is a n minus 1. So dependency depends on what efficiency means, whether we find out whether the worst case, best case and average case. So what is the best case means, the first element itself is a maximum value appadina, it returns the, this is a best case. So the maximum elements is lies at the nth element, that is the worst case. If that maximum elements is lies at the in the middle appadina, it is an average case. So there is a general plan for analyzing the time efficiency for non-recursive algorithms. First decide on a parameter indicating what is the input size. So for the first step we have to decide what is the input size. So identify the algorithm's basic operation. So the basic, as a rule, the basic operation inside the for loop, the innermost loop, how much time, what is the statement is located inner loop in the inside the for loop. Third step, check whether number of times the basic operation is executed. So it depends upon the input size. If it also depends on the some additional property, that is the worst case, average case and best case efficiencies. So the fourth step, set up a sum expressing the number of times the algorithm's basic operation is executed. So we have to set up the sum for how much time the basic operation is executed. So using the standard formula and rules of sum manipulation, either find the closed form formula for the count or at very least establish in order of the goal. We have to find out what is the efficiency of an algorithm. So this is a general plan for the algorithm. In the previous slide itself, we see that for the given algorithm, what is the input size and what is the basic operation and how much time the basic operation is executed. So for formula for the sum manipulation, there is two formulas for sum manipulation. If summation is equal to I is equal to 1 to n, when C A of I means we have to see the constant value of C is comes out from the for loop, that is C is comes out, finally summation is I is equal to 1 to n A of I. So there is another condition, another statement for summation of I is equal to 1 to n. For A of I plus or minus B of I is equal to means we can add A of I separately and B of I separately. So this is the two sum manipulation algorithm. So next two sum formulas for the non-recursive algorithm is, one is summation is equal to I is equal to 1 to n, that is 1. So in that is equal to upper bound minus lower bound plus 1. So where the lower bound is less than or equal to u. Next summation is summation formula is sum is equal to 1 to n, that is an I. That means the I means that is a 1 plus 2 plus up to n. So the finally we get the n into n plus 1 divided by 2. So this is the two summation formula we can use in the any non-recursive algorithm. So the any non-recursive algorithm lies between only these two formulas. This is about that how the analysis of an algorithm is executed. So the previous in the largest of element, the basic operation is that is for inside the statement inside the for loop. So how much time the for loop is executed means summation is equal to I is equal to n minus 1. That the statement is executed exactly one time for every for loop incremented. So the lower bound, upper bound minus lower bound plus 1. So the n minus 1 minus 1 plus 1. So the result will be n minus 1. So finally we get the order of n is an efficiency of this largest of element in the given array. So next example is the same we can analyze the non-recursive for next example, the find the element uniqueness problems. So what is that problem? So we have to, for the given array, we have to find out the distinct element, whether the element is unique or distinct. If it is distinct means it returns true, if it is unique means it returns false. This is the problem for the element uniqueness problems. So for that algorithm, first there is a problem description. So the input statement is an array is 0 to n minus 1. So output appadina it returns true if all the elements A are distinct, otherwise it returns the false. This is an output of the element uniqueness problems. So in that we are using the two for loop. One is for I is equal to 0 to n minus 2. So what is the why we use the two for loop means we have to check the two elements. First element to second element, if it is equal to or not. If it is not, then it moves to the another thing. So we are for that we are using the two for loop for I is equal to 0 to n minus 2 and j is equal to I plus 1 to n minus 1 So the inside the statement, the statement inside the for loop is there is a conditional statement. If A of I is equal to A of j, if it is equal to means it returns false, if it is not means it returns true. This is the algorithm for the uniqueness problems. So for that problem, first we have to analyze based upon the general plan of non-recursive algorithm, what is the problem size. The problem size is n. So what is the basic operation? The basic operation is comparison between A of I to A of j. So the how much time the basic operation is executed means based on the two for loops the basic operation is executed. So the first for loop I is equal to 0 to n minus 2, then summation of j is equal to I plus 1 minus n minus 1, that is these two for loops executed that statement every time exactly once. So finally we have to find out the efficiency based upon the best case and average case. So what is the worst case means? All the elements are different in the given loop, mean that is the worst case. The best case means first and second element are same அப்படினா return false, that is the best case of the formula. So for that we have to analyze the algorithm based upon the two formulas, some for loop. So the worst case is calculated based on the two for loops executed exactly one. So summation of I is equal to 0 to n minus 2, the summation of j is equal to I plus 1 to n minus 1, that is 1. So in that, in the inner loop is first calculated, after that the outer loop is calculated. So after doing the formulation, finally we get that n into n minus 1 into n divided by 2, that means that is more or less equal to 1 by 2 n square. So the finally the order of the worst case complexity of uniqueness problem is order of n square. So this is the thing we can analyze this for the uniqueness of problems. The worst case efficiency of the uniqueness problem is order of n square. So for every non-recursive algorithms we can use only these two summation problems, either 1 or I. Based upon that we can find out the worst case, best case and average case efficiency. Thank you.